Hello, welcome back to my recorded classes. This video we are discussing the topic from module 4 counting 4.3.1 permutations. Okay, in 4.3 section, first idea. Okay, actually 4.3 section we have mainly three ideas. This is the first idea, permutations. So before starting the topic, all of you please subscribe my channel for getting more recorded classes. So let's start the topic. Section number 4.3 actually permutations and combinations, correct? So this section mainly we are studying three ideas. One is what is permutation, we are calling it is first section 4.3.1. Then we are studying combinations 4.3.2 and inclusion and exclusion principle we are discussing in 4.3.3. okay, so I will add separate recorded classes all these three sessions separately. Okay, so first topic we are going to discuss is permutations 4.3.1. okay, from this section 4.3. so what is the meaning of permutation? Okay, permutation of a set of elements is just an arrangement. Okay, permutation means nothing but it is the arrangement of all object or a part of the elements, part of the object in a definite order. Okay, order is very important here. It should be in a definite order and it is an arrangement of object. Okay, arrangement of a part of the object, all the object we are arranging in a definite order, correct? So this is what we are calling permutation. A simple example you can understood that one. After that I will come to the definition again. Okay, example 1, the number of three letters. Okay, how many letter word? Number of three letter words with or without meaning which can be formed out the letters of the word number. Okay, a part of the question, write the repetition of the letters is not allowed, correct? Where the repetition of the letters is not allowed. If the repetition of the letters is allowed, okay, these two cases write the number of permutations or number of the three letter words with or without meaning that can be formed out from the letters of the word number. So you can see here, simply we can understand this idea. What is the word here? Number, correct? N-U-M-B-E-R, correct? Number. Now when we are taking this word, how many letters are there in this word? You can calculate that one, correct? 1, 2, 3, 4, 5, 6 letters we have totally, correct? 1, this is second, third, 4, 5 and 6 letters we have totally, correct? So totally 6 letters, but using these 6 letters we need to create 3 letter words. Okay, how many letters words we need to create? 3 letter word only. That is the question here. Okay, we need to create 3 letter word. That means first letter, second letter and third letter. Okay, 3 letter word. How many 3 letter words we can create from the letters of the word number, correct? That means using these 6 letters. First question, where repetition of the letters is not allowed. Okay, repetition of the letters is not allowed. That case, how many words we can form using 3 letters of the word, correct? So what we will do actually is this is what we are doing is by using permutation. Okay, that means totally how many letters we have? Totally we have 6 letters, correct? So I am writing n equal to 6. N equal to 6 here. That means total number of letters equal to 6. Now how many letter word we need to create? Correct? 3 letter word we need to create. So just take it as represent R. Okay, R equal to 3. Correct? How many letter word we are creating? That means 3 letter word we are creating. That means how many letters we are taking at a time. That is the meaning. So n equal to 6, R equal to 3. Now how many words like that we can form is we are calling the permutation. We can find by using permutation. We are always representing P in bracket. How many total letters we have? We have 6 letters. How many we are taking at a time? That is 3. P6 3. That means permutation of 6 letter totally, 3 taking at a time, correct? First number is the n number and second number is the R number. Now see this how we are calculating using the calculator, that is equal to, you know, calculator there is permutation option. You can see NCR option, NPR option, that means 6. Okay, 6 is the total letters permuting. How many at a time we are taking? That is 3. 6p3. You can enter that in your calculator. Where is this coming? You know, shift button and multiply button in calculator. You can use the shift button. After that you can use the multiply button, correct? So the permutations which you are getting, so first you enter the number 6, after that shift button, then multiply button, so p will come, then the second number, that is 3, so 6p3, correct? So that you are getting the answer. What is the total permutation we are getting? 6p3, that means you are getting 120 here. I am writing the answer here, equal to 120. 120 words we can form. Okay, 120 ways we can arrange that 3-letter word. Now this question we can do same question another way also. See, I am just writing here or we can do like this. Okay, or that question how can we do that also I will just explain here, so that you can understood easily that one. Other ways how we are doing this question, correct? How many letter word we need to create? 3-letter word we are creating, correct? So this is the first box representing the first letter, this is second letter, this is the third letter. Now in the first letter how many possibilities are there? You can think that one. How many letter available here? 6 letter we can apply here, correct? Either n number or u number or m number or b or e or number, that any letter, correct? So 6 letter totally. So in the first box, because 3-letter word we need to create, first letter 6 possibilities are there, correct? Now we asked the question, repetition is not allowed. Repetition of the letters are not allowed. So in the first option 6 letter means second box how many letter possible? 5, because one letter we are written in the first box means that letter we cannot write in the second box, correct? Repetition not allowed. So how many letters are possible in the second position or second letter? As 5 letters. Now first box we written one letter, second also we wrote one letter, means that cannot write in the third box. Repetition not allowed. So how many possibility we have in the third letter? That is 4 options, correct? So totally by using multiplication rule, totally how many ways we can arrange this one? 6 multiply 5 multiply 4, correct? That means what is the number getting? Same as equal to 120 ways we are getting. Okay, 120 ways totally we can arrange the 3-letter word from 6 letters. I hope you understood that one. Okay, so this idea we can do like this, the permutation directly by using calculator, or like this also we can do. Okay, the second way we are studied in 4.1 section, like this arrangement, correct? Okay, now I will go to the B part of the question. What is the idea of the B part of the question? Okay, just forming the idea here. B part of the question. What is the B part? If the repetition of the letters is allowed, you can repeat the letter, no problem. That is the meaning. Repetition of the letters is allowed. That means you can see how many letters we need to create? 3 letters, correct? 3-letter word we need to create. So first letter, second letter and third letter, correct? Now how many letters we have totally? 6 letters. So first option 6 possibilities are there, correct? That word first letter there are 6 possibility. Number you can you can use u, b, e, r, correct? Now whatever we are written in the first letter, that same letter you can write second also, because repetition is allowed, correct? So how many option will get in the second box? That also 6, correct? And how many option will get third box? That also equal to 6, correct? Because repetition of the letters are allowed. It is allowed, correct? So how many totally we are getting? It is equal to 216. 6 multiply 6 multiply 6, correct? By using multiplication rule, that is equal to 216 ways we can arrange. 216 ways we can arrange the 3-letter word, or we can generate the 3-letter word from 6 letters, correct? So 6 multiply 6 multiply 6, or we can write how it is, 6 power 3, correct? 6 how many times coming? 3 times. So 6 multiply 6 multiply 6 means 6 power 3, that means equal to 216. Okay, 216. Now what is the meaning actually this 6 power 3? 6 means n number, correct? N number, that means we can write like a rule, n power 3 means what is that number? R number. So n power r. This is the rule for finding the permutation with repetition. Okay, this 6 means this is actually r letter, sorry, n letter, and 3 means this is like r letter. So n power r ways we can arrange totally, correct? So if repetition not allowed, p n r, correct? That is the idea. If repetition allowed, n power r ways we can arrange the letters of the word number. I hope you understood that one. Okay, so what we are studied is, if you are getting a question like this, number, okay, just a short way I am telling, if you are getting a question number, this word, how many ways we can arrange 3 letter, or how many 3 letter words we can create by using the letters of the word number, 3 letter word, correct? And how many ways we can create 3 letter word, correct, from the word number, okay, with repetition or without repetition. This is without repeat, okay, and this is with repeat, with the repetition, how many we can form. This is what we did that question, with repeat or without repeat. Without repeat means how many options we written? First 6 option, then 5 option, then 4 option, correct? 6 multiply 5 multiply 4, we are getting 120, correct? Now if repetition allowed means, first we have 6 possibility, second also 6 possibility, third also 6 possibility. So totally how many possibilities we are getting? We are getting like 216 possibilities, 216 ways, correct? Now what was the rule I told in both cases? You remember, without repetition means what we are doing is, by using calculator easily we can calculate this number. How we are doing? Permutation of total n object taking r at a time, PNR, correct? PNR means here n means 6 letters, r means we are taking 3 letter at a time. So same answer you are getting 120 ways we can arrange, correct? Now see, if repetition allowed means, what I told, the rule is n power r, total letters power how many we are taking at a time. N power r means 6 power 3, correct? So that also same answer you are getting 216. Okay, so this is the idea of the first question, with repetition and without repetition, how many ways we can arrange, 3 letter word, correct? All the letters we are not taken, 3 letter we are taken. Okay, so this is the answer for that one. So here I am given the solution here for your reading, how many words we can create. Okay, so first one 120 and second one is 216, repetition is allowed. Okay, now let me go to the another question. So this example, what I want to tell is number. We are not taking all the letter at a time, only 3 letter at a time. That is why in the definition it is mentioned, permutation is the set of elements, is arrangement of all or a part of the element. Part of the element means number. See, we are not taken all the letter at a time. How many letter we are taken? 3 letter. That is why the part of the elements in a definite order. Sometime we are taking all. Okay, now we are discussing one example, all letter taking. All the letter taking, one example now we are going to discuss here. Now you can see the second example, example number 2. The number of 4 letter word. How many letter? 4 letter word. Okay, with or without meaning, which can be formed out of the letters rose. What is our word here? ROSE, correct? This is our word, rose. How many letters are there totally? We have 4 letters, n equal to 4, correct? And you can see all the letters are distinct letters. R coming only one time, O coming only one time, S coming only one time, E coming also only one time, correct? So like this word we are calling distinct. Okay, distinct words. Okay, distinct word, each letter coming only one time. So whenever you are getting a question like this, first you think, is it distinct or not distinct? Okay, it is distinct here. ROSE, all letters only one time. The previous example also only one time came, number. Okay, that example also. Now here total letters equal to 4. Now what is our question? How many, the number of 4 letter word we need to create? 4 letter. Okay, so from this I need to create a 4-letter word, correct? 1, 2, 3 and 4. 4-letter word I want to create from here, okay? And this 4-letter word, how we need to create? Where the repetition of the letter not allowed. Repetition not allowed, okay? So I am writing here, not repeat. That is the first part of the question. How many ways we can, how many words we can create 4-letter word? And second part of the question, with repeat. Repetition of the letters is allowed, correct? So we need to create a 4-letter word. We need to create the 4-letter word, the repetition allowed, correct? So I can write with repeat, correct? With repeat, that means repetition is allowed. Now you can tell me what are the possibility here. You can think and tell me how many letter totally we have. N equal to 4. How many letter word we need to create? That also 4, correct? R equal to 4 here. 4-letter word we need to create from 4-letter word, correct? So all the letters we are taking at a time, okay? All the letter in this example we are taking at a time. So what is the rule actually? First, not repeat, without repetition. What was the rule? Permutation of totally 4 object. How many we are taking at a time? 4 we are taking at a time, correct? Permutation of 4 object and 4 we are taking at a time. You can check by calculator that one. Like 4 first we are entering, then shift button, multiply button, that is P, permutation 4, correct? So that you are getting it is equal to 24. Equal to 24 we are getting. Yes. Now the same idea we can do another way, as I told you. How we are doing? Another way we can check it now. Okay. Another way we are doing. This is the OR way. Okay. Other ways. So how many letters we have? 4 letters. We need to create 4-letter word, correct? See, the first box is the first letter, second box second letter, third and fourth, correct? So in the first letter, how many possibilities we have? We have 4 possibility, 4 letters we have. R, O, S, E, correct? So I am writing 4 here. Now repetition not allowed, not repeat, correct? So how many possibilities are in the second letter? 3 possibility only, because first 1 letter we are written in the first box means that letter we cannot write second. So only 3 possibility. Same like third box, how many possibility it will come? Only 2. Fourth box, how many it will come? Only 1. Correct? So by multiplication rule, what is the total possibility? 4 multiply, 3 multiply, 2 multiply, 1. Correct? That is equal to 24. The same answer we are getting, equal to 24. I hope you understood that one without repetition, not repeat. Correct? P4 either you can do like P4 permutation of 4 object 4 at a time, 24, or we can do like this boxes, how many possibility in the first, second, third, fourth, like that. Okay, this is the A part of the question. Now I am coming to the B part of the question. What is the B part of the question? Repetition of the letters is allowed. Correct? 4 letters only, but you can repeat the letters, no problem. So what was the rule I told? Repetition allowed. N power R, correct? So what is n power R? N means what is the total number of letters? 4. How many we are taking at a time? 4. So 4 power 4 we are getting, correct? 4 power 4 we are getting. You can use the calculator, you will get 256. Equal to 256 ways we can arrange the 4 letters, correct? Now how we are doing another way, the OR way. Second way, how can we do? You can think about the possibility in the first word, correct? First letter. How many letters are possible? Totally we have 4 letters, correct? 4 letter word we need to create. This is the first letter, second letter, third letter, fourth letter. First letter, how many possibilities are there? 4 possibilities. What are the 4 possibilities? R, O, S, E, correct? 4 possibilities. Second, repetition allowed. Repetition allowed means here also how many possibility? 4. Same 4 letters we can write here in third also. Same 4 letters we can write in the fourth position also, correct? So what is the total number of ways arrangement? 4 multiply 4 multiply 4 multiply 4. That means equal to 256 ways we can arrange that word rows. I hope you understood this question. Okay, idea is easy. Try to clear. Because this is like logical questions, understanding is more important. Okay, now you can see the solution, the previous question, same whatever we are discussed now. I wrote here permutation of 4 different letters taken all at a time, all at a time, correct? All the letters means all 4 letters at a time. How many letters we have? 4 letters, correct? So totally we are getting 4p4, that means equal to 24. Otherwise 4 multiply 3 multiply 2 multiply 1 equal to 24. Now if repetition allowed means, as I told you, n power r or 4 power r, 256. Otherwise 4 multiply 4 multiply 4 multiply and 4, 256 we are getting. Okay, I hope you understood that one. Okay, now let me come to the definition now. Permutation definition. So from these two examples, I hope you understood what is the meaning of permutation. Permutation means it is the arrangement of the object. A set of objects we are arranging in a specific order. You can take the full object or part of the object at a time, correct? Now how can we define this one? The number of permutations, okay, number of permutations of n different object. How many object totally? N object taken r at a time. How many we are taking at a time? R at a time, correct? And object do not repeat, without repetition. It's denoted by, we can denote PNR, permutation of n object r at a time. Or we can represent like this, NPR, n object totally permuting r at a time, is given by, what is the rule actually? This is the rule. Okay, when we are entering your calculator, you will get the answer, correct? So what is the rule programmed in the calculator? You can see this is the rule. PNR or NPR equal to n factorial divided by n minus r factorial, correct? N factorial divided by n minus r factorial. So using this rule, you can find how many permutation. What is the value of PNR, permutation of n total object taken r at a time? Okay, you will get from here. Now this is without repetition, not repeat, correct? Repetition not allowed, that case. Now if the repetition allowed, number of permutation of n different object take r at a time, where repetition allowed means, what is the rule? N power r, n power r, that is the rule for finding the permutation. N power r, that means total power, how many we are taking at a time. Okay, n power r. So we discussed that in examples. I hope you clear to that one. Okay, now before coming to the next example, just to see what is the meaning of factorial notation. You know the factorial notation before, but just for review, just revision, factorial notation. Okay, what is 0 factorial actually? 0 factorial is 0. 0 factorial is 1. Okay, generally we are telling 0 factorial is 1. 1 factorial also 1. Okay, how you are checking factorial? You can alternatively you can check by calculator also. You know how to check factorial? Shift button, correct? This switch you can use. After that you can see x power minus 1, this switch, correct? Downside you can see the factorial symbol, correct? Shift x power minus 1. For example, if you want to calculate 7 factorial, what we do? 7 shift x power minus 1. So 7 factorial will come. You will get 5040, this one. Now what is the meaning actually factorial? Factorial meaning is, for example, 7 factorial. What is the meaning 7 factorial? Starting from number 1 up to number 7. Okay, always starting from number 1, always multiply up to this 7 factorial means up to 7. So 1 multiply, 2 multiply, 3 multiply, 4 multiply, 5 multiply, 6 multiply 7. So totally you will get 5040. Same like, sir, for example, 5 factorial. What is 5 factorial? Starting from number 1 up to 5. Multiply all the number. 1 multiply, 2 multiply, 3 multiply, 4 multiply 5 equal to 120. Correct? Same, for example, 3 factorial. How we are calculating 3 factorial? Starting from number 1 up to 3. So 1 multiply, 2 multiply, 3. So what will be the answer? You can check 6. Correct? Equal to 6. This is the factorial notation. Already you know that one before. Briefly I am telling the ideas here. Okay, you can see that one. So equal to 6. I hope you understood that one. Only remember 0 factorial. 0 factorial is 1. 1 factorial also equal to 1. Okay, now let me go to one example. Evaluate the value of 7p2. 7 permutation 2 at a time, correct? 7p2 value without using calculator is doing. Okay, without using calculator, 7p2. So 7p2 equal to, what is the rule we are studied? npr means, what is the rule? N factorial divided by n minus r factorial, correct? Now here 7p2. So what will be the n value here? N equal to 7. Okay, p2, that means r value equal to 2, correct? Because 7p2, this is the n value, this is the r value. Okay, now 7p2, how can we write that one? N factorial means 7 factorial divided by n minus r factorial, 7 minus 2 factorial. That means 7 factorial divided by 7 minus 2 means 5 factorial, correct? Now what is the meaning of 7 factorial? I told 1 multiply, 2 multiply, 3 multiply up to 7, correct? Divided by 5 factorial means 1 multiply, 2 multiply, 3 multiply, 4 multiply, 5 there, correct? Now what term we can cancel? 1, 2, 3, 4, 5. We can cancel with 1, 2, 3, 4, 5, correct? The down numbers. So what will be the balance? 6 multiply 7. 6 multiply 7 means what will be the answer? Equal to 42, correct? Same thing, if you are entering your calculator also, you will get the same number, equal to 42. So this question we did manual way, okay, without using calculator. How can we calculate the 7p2 permutation values? Okay, because software or most of the programming students, they want to know how to create the code for finding the permutation, correct? So this is the way for calculating that one. Hope you understood that one. Okay, now let me go to one example here. Example here, 6 candidates are called for an interview. How many candidates? We have 6 candidates. Okay, so I am writing here n equal to 6. We have totally 6 candidates called for an interview. Okay, to fill 4 posts. How many posts we have vacancies? How many jobs? Post means jobs, correct? We have 4 posts filling in an office. 1, 2, 3 and 4. This is the post 1. Post 1 means job 1. Post 2, third post and fourth post. Okay, we have 6 pupils. We need to fill 4 posts or 4 job. Okay, assuming that each candidate fit for the post. All 6 candidates are eligible for the job. Okay, all these posts. Determine the number of ways in which first and second post can be filled. That is the first part of the question. First post and second post, how many ways we can fill out of these 6 people? Okay, first post and second post, how many ways we can fill this post? That is the first question we need to do. Okay, so I can show that answer here, the first part of the question. Okay, how many posts we need to fill that one? 2 posts, correct? This is post number 1. This is post number 2. We are not filling all the posts in the first question. First post and second post, how many ways we can fill? That is the question. Okay, so what is the total candidate? Total number of candidate? 6, correct? How many posts we need to fill? R equal to 2 posts, correct? Post 1 and post 2. So how many permutation we can? How many ways we can arrange these 6 pupils in 2 posts? Permutation of totally 6 pupils, 2 we are taking at a time. 2 pupils we are taking at a time, because 2 posts only we are filling. You can check the answer. What is the permutation of 6 and 2? It is 30. Answer are given here. You can check in calculator also. So totally you are getting equal to 30. Correct? You know how to enter that P62 in calculator. Correct? How we are entering it in calculator? 6 permutation 2, like this. Correct? So you will get equal to 30. Hope you understood that one. Correct? So this is the one way we are doing. Okay, other way, the same question as I told you, how can we do in other way? Second way. Okay, I will tell you here how can we do the second way. For example, how many posts we need to fill in the first question? First post and second post, only 2 posts, correct? P1 and P2. Okay, how many pupils we have? 6 pupils. So how many ways we can select a person to the first post? There are 6 people. 6 are eligible. All are eligible. Correct? One of the person from 6 we are selecting to the first post. Post number 1. So 6 people, 6 possibilities are there. Correct? Either first person or second person or third person. Like 6 persons are there. So 6 possibilities are there. Now repetition not allowed. Correct? One person appointed in the first post means that person cannot be in the second post, second job. Correct? So how many ways in the second post we can fill? 5 ways. Correct? Totally 6 people, 1 person appointed in first job. So that person should not be in the second job. So 5 persons. So totally how many ways we can do? By multiplication rule, 6 multiply 5, that is equal to 30 ways. Correct? 30 ways we can arrange for the post can be filled. First and second post can be filled. This is the first part of the question. I hope you understood that one, the first part. Correct? Yeah. Now we will go to the second part of the question. Okay. So you can read the second part of the question. Okay. What is the second part? First 3 posts can be filled. First 3 posts. How many posts we can need to fill? First post we need to fill, second post and third post. If you are thinking like this, it is easy to clear the question. Okay. First post, second and third post. How many ways we can fill first 3 posts? That is the question. So we can go to that one. What is the total number of persons? 6. How many posts we need to fill? 3. Correct? That means 3 persons needed. So out of the 6 person, 3 person we are selecting at a time. Correct? So permutation of 6 pupils, 3 we are selecting at a time because 3 posts. Correct? So you can check the number. What is the permutation of P63? That means the answer is 120. 120 ways we can fill the post, that one. Correct? Other ways, if you are doing like this also, okay. Or you can think about first post. How many persons, how many possibilities are there? 6 possibilities because 6 pupils are there. Now 1 person appointed in the first post means second post 5 persons will be there possibility, and third post we have 4 possibility will be there. Correct? Because repetition not allowed. First person appointed in first post means that person cannot be in second. Okay, second person cannot be in third. First and second person cannot be in third. So 4 post only. 4 person, 4 possibility only. So totally how many possibilities? 6 multiply 5 multiply 4 we are getting. That is totally 120 ways we can arrange. Okay, so the same answer we will get. So one of the way you can do when we are answering the questions. Okay, totally 120 ways. Okay, now the third part of the question. All 4 posts can be filled. All 4 posts. Okay, all the 4 posts we can fill means how many ways? Okay, so I can go to the third question now. All 4 posts. So first post, second job, third job and 4th job. Okay, P1, P2, P3 and P4. First post, second, third, fourth. So how many total persons? 6. Correct? How many posts we need to fill? All 4 posts. So in R equal to 4. Correct? We have R equal to 4 here. So what is the permutation? How many ways we can fill that all 4 posts? Permutation of 6, 4 taken at a time. Correct? So what will be the answer? You can check 360 ways. We can fill 360 ways. Correct? So I hope you understood. Other ways we can do the question, same question like this. What is the same question we can do? First post, how many possibility? There are 6 pupils. One of the person can appoint there. Correct? Now 1 person here appointed means second how many persons available? 5 possibilities. Third how many possibility? 1 more reducing, 4. Fourth how many possibility? 1 more reducing, that is 3. So totally how many ways? 6 multiply 5 multiply 4 multiply 3 we are getting. That means totally we are getting 360 ways we can arrange all these 4 post filling. Correct? Okay, I hope you understood. Now you can see the solution, the same question. First 2 post means P62 and first 3 post means P63 and all 4 post means 360. Okay, so the same idea, answer I just given here for your reference. Okay, now we will go to the example number 5 now. Example number 5. Okay, now what is the example number 5? How many words with or without meaning? Some word may be no meaning, no problem. With or without meaning can be formed from the letters of the word maths. This is the word maths. Okay, so I can write here MATHS. This is our word maths. Correct? How many words can be formed from the letters of the word maths? Okay, with or without repetition, with or without meaning, no letter of the word is repeated, repetition not allowed, that is the meaning. Okay, no letters of the word is repeated, repetition not allowed. Okay, how many ways we can create, that is what our question. So you can see first this word, is it distinct or not distinct? It is distinct because each letter coming how many times? Only one time, correct? So we can write distinct, mem letter coming only one time, a letter one time, t letter one, h one, s one. So distinct, correct? Now how many words, how many letters are there here in this word maths? N equal to total number of letters m1, a2, ht, hth, s. So totally 5 letters are there, correct? Totally we have 5 letters are there. Now you can read the first part of the question. 4 letters are used at a time. Okay, out of 5 letters, 4 letters are using at a time. How many words we can create? Okay, how many words can be formed? Okay, with or without meaning, that is first part of the question. Okay, so we can see that one. Assume in your mind we need to create 4 letter word. This is the first letter, second letter, third letter and fourth letter, correct? Totally how many letter? 5 letter we have, correct? So how many letter we need to take at a time? 4 letter, correct? R equal to 4, n equal to 5, but R equal to 4 here. So how many ways we can create? Total ways, okay, or number of ways. We can write like number of ways equals permutation of totally 5 letters, 4 taking at a time. Permutation of 5, 4. You can check the calculator, what is that number? Permutation of 5, 4 means 120. Okay, I was written the answer on the next slide. So 120, correct? We got the answer now here. Now the same question as I told you, we can do another way like this. We need to create 4 letter word, first letter, second letter, third letter and fourth letter. How many letters are available? 5 letters. So first box there are 5 possibility, correct? 5 possible letters are there. M, A, T, H, S. One of the letter we can write in the first box. Second box, no repetition allowed. So first letter, first box, whatever letter you written, we cannot write in the second box that one. So how many possibility? We have 4 possibility. Third one we have 3 possibility. Then we have 2 possibility, correct? So 5 multiply 4. Totally how many ways? 5 multiply 4. 20, 20 multiply 3, 60, 60 multiply 2, 120 ways. We can arrange 120 ways totally, correct? So like this we can do, or like this we can do, as your wish. I hope you understood that one, correct? Now the second part of the question, all the letters we are used at a time, how many words we can create? Okay, I will do in the B part of the question or second part of the question. Totally how many letter we have? We have 5 letters, correct? N equal to 5 already here. All the letters are using from 5, all 5 we are using. That means R equal to how much? Same 5. So how many ways we can? Number of ways equal to how many permutations actually? Number of ways equal to permutation of 5 object, 5 at a time, correct? All the letters we are taking at a time. You can check the calculator, you will get the answer 120 equal to 120. I hope you understood that one, correct? Now the same question as I told you, we can do another way. How many letter word we are creating? 5 letter. All the letter we are taking at a time. So 1, 2, 3, 4 and 5, correct? Now how many ways we can write? In the first letter how many possibility? There are 5 letters, so 5 possibility. Second letter repetition not allowed, so 4 possibility. Third one 3, fourth one 2 and fifth one 1. So by using multiplication rule, 5 multiply 4 multiply 3 multiply 2 multiply 1, correct? So totally how many we will get? 120 ways we can arrange. Hope you understood this question, correct? The idea is important, idea only, just remember. Now the third part of the question. What is the third part? All the letters are used at a time. All 5 letters we are using at a time. But what is the problem? The first letter is either A letter or S letter. Okay, first letter either A letter or S letter. That is the question here, correct? So how many letter word we need to create here in third part of the question? We need to create a 5 letter word. 1, 2, 3, 4 and 5 letter, correct? First letter, second letter, third letter, fourth letter and fifth letter. But what is the condition? First letter is either A or S, correct? First letter. So I can mark here in the first letter. What are the possibility? Either A or S. Only two possibility, correct? So I can write here 2. Only 2 letters only we can write there. Either A letter or S letter. Totally how many letter we have? Totally we have n equal to 5. 5 letters we have. So out of this 5 letter, one of the letter you will write here, correct? Either A letter or S letter. So how many letter possibility here in the second position? Second position we have 4 possibility, correct? Because if you write A here, yes, we can write next position, correct? So 5 out of 5, one letter only we are writing first box. 2 possibilities are there, but writing one letter, correct? So 4 possibility in the second box, and next 3 possibility, next 2 possibility, next 1 possibility, because repetition not allowed, correct? So think about that one. Here this question, what is the thinking? No, the first letter either A or S. So one letter. So here you write one letter, but how many possibility? 2 possibility, correct? I am writing here possibility, okay? How many possibility? 2 possibility is there, A or S, but you are writing one letter, correct? Now how many letter balance to write here? Totally we have 4 letter balance, because totally 5 letters, one letter first letter already written, so 4 letter balance. So 4, 3, 2, 1 we are arranging. So as per the multiplication rule, what is the total possibility or total number of ways? 2 multiply, 4 multiply, 3 multiply, 2 multiply 1, correct? You will get the answer. You can check what answer getting. That means 48 we are getting. Totally equal to 48 ways. You understood? Okay. Now the same question as I told you, what is the first way we are doing? Okay, first way, how can we do that one? You can think like this. See, I am again here 3, 4, 5, correct? 5 letter word. First letter, as I told you, we have 2 possibility, either A or S, correct? A letter or S letter. Here totally how many letters remaining? 4 letter. 4 letter, correct? Here first position, how many possibility we have? 2 possibility. So 2 multiply, okay? First box 2 possibility, that is 2 multiply. Now here how many letter totally we have? 4 letter. Out of the 4 letter, how many letter we need to fill? Here 1, here 2, here 3, here 4. 4 out of 4, correct? So permutation of remaining 4 letter, 4 we need to take at a time, correct? 2 multiply permutation of from 4 letter, 4 we are taking at a time. You understood? Because we have 4 boxes pending. How many letter remaining? 4 letter. Totally 5 letter, but 1 letter first box we are writing. So totally 4 letter here available. So 2 multiply permutation of 4, 4. This is also you will get the same answer from calculator. That means the 48 ways. Hope you understood this question. So this is the third part of the question. All the letters are used at a time, but the first letter is either A letter or S letter. 2 possibilities, okay? Now, so this answer it is mentioned here, first answer, and third answer I am written here directly, 2 multiply P44, that is as I told you here 48 ways, okay? Now before going to next example, one important idea we are discussing here. There are 2 type of permutation here we are discussing. One is linear type of permutation. Second one is circular permutation. Linear permutation only up to now we are studied. What is the meaning linear permutation? If the objects are arranged in a line or a row, okay? If objects are arranging like a line or a row wise we are arranging like this, okay? This is the line, correct? Line wise we are arranging. First object here arranging, second, third, fourth, fifth, like that. 1, 2, 3, 4, 5, 6. Like objects are arranging like a line or a row. Okay, this type of arrangement we are calling the linear permutation. Okay, now if you are arranging the object like a circle, Okay, first object you are arranging here. Okay, second, third, four, like this. Okay, if you are arranging the object like a circle, that is what we are calling circular permutation. You can see objects are arranged in a circle, then it is calling circular permutation. Objects are arranged in a line or a row, then the permutation is called linear permutation. For example, here, see, I have given here four colors. This is the first color, red color, second color is blue color, third color is yellow color, fourth color is green color, correct? Four color we are taking. This four color I want to arrange one by one. Okay, I want to take different permutation, different arrangement, these four colors. For example, you can see the first row, all colors are red here. See, then second row all red. Red changed into third row, red changed into fourth row. So how many ways totally we can arrange? 24 ways, correct? How we are that one? Totally how many colors are there? N equal to 4, correct? How many colors we are taking at a time? R equal to 4. 4 colors we are arranging. So what is the permutation? Permutation of 4 object, 4 taking at a time, correct? P4, 4. You can check by calculator, you know how to check that one. You will get 24. 24 ways we can arrange, correct? So this is the 24 way. This example you can see 24 ways we can arrange like this, correct? So this is what we are calling linear permutation. Okay, so arranging by a line. Now if the objects are arranging in a circle, what happening arranging in a circle? You know the circular meetings are when we are conducting meeting in a circle, correct? So that means around a table people are sitting, correct? So the first person, for example Abdullah, he is sitting here, and second person Amin, he is sitting here, correct? And the third one Huda, he is sitting here. Fourth one Muna, she is sitting here, correct? So like this, Abdullah and Amin and Huda and Muna, they are sitting like a table. How many ways they can arrange this around this table? That is what we are calling circular permutation, correct? Circular permutation. See, these four objects, for example, I am represented here color. This is red color, you know, this is yellow color, and this is blue color, and here it is green color. How many ways we are arranged? You can see 1, 2, 3, 4, 5, 6 ways, correct? 6 ways we are arranged the object, correct? Red, yellow, blue, and green. We are arranged like peoples Abdullah, Amin, Huda and Muna, like this, correct? So see what happening here in this circular permutation. Abdullah, for example, if I am taking this direction, Amin is the near to Abdullah. Amin near, Huda is the near, correct? Huda near Muna, correct? Muna near Abdullah is there, correct? So near person you can see, like that we need to arrange it. Okay, now this example, see the red color, yellow color, blue color and green color. See 6 ways I can arrange that one. Okay, when we are arranging, don't take the permutation of the rotation. Rotation don't consider. Okay, so that is why their number is 6. For example, here in this circle, okay, I can draw here. For example, here Abdullah, as I told you, here Amin is there, and here Huda is there, Huda is sitting, and here Muna is sitting, correct? This order. Now see, Abdullah near is Amin, Amin near is Huda, Huda near is Muna, Muna near Abdullah, correct? Like this. I can write like letter, this is A, for example this is B, and this is C and D, correct? This is one permutation. What is that permutation actually? A, B, C and D, correct? This is the one way of arrangement. Now for example, if you are rotating like this Abdullah, okay, if I am rotating like this, okay, for example, then how it is coming like this? Abdullah was here, now he is coming to here, correct? Abdullah here, and Amin was here in the Abdullah position, now Amin is coming here. Just to rotate like this, you can think about that one. Now Huda is coming here, correct? And Muna is coming here. So now, so is there any change happened here in the previous arrangement? Same array, same near places. For example, here also Abdullah near is Amin only, Amin near Huda only, correct? Huda near Muna only, Muna near again Abdullah only, correct? So what happened here? A came, and here B, and here C, and here D. We just rotated that one, correct? Like this permutation we are calling identical permutation. What we are calling? Identical. For example, what is the permutation here? You can see, you can start from D. So D, A, B, correct? C. D, A, B, C. So this is a permutation, correct? D, A, B, C, or same like A, B, C, D. D, A, B, C, correct? So these two permutation we are calling identical permutation. So when we are writing this here, this 6, we are writing 6 different one, okay, not near same like what we discussed, different one we are taking. So different way when we are arranging, we will get 6 permutations, circular permutations are getting, okay. So if you are taking like this permutation, we are calling that one identical permutation. So what we are discussing here, see, two circular permutations are said to be identical. What is the meaning? If one of them can be formed from other by rotation. See this figure, this picture you can see. See, this is A, B, C and D, correct? You can see this one. A, what is that permutation? A, B, C and D, correct? Now if you are rotating, this A will come here, correct? So see here, A is here now. So A, B, C, D. So what is that permutation? D, A, B, C. That is same as A, B, C, D, just rotating only. Again one more time rotating means what happened? This A will come here, correct? One more time rotated. So what is that permutation? C, D, A, B. Same A, B, C, D, correct? Only rotation change. One more time rotation means A come here. So what happened? We are getting B, C, D, A, correct? This is another permutation. These permutation, what we are calling? This is what we are calling identical permutation. Identical, correct? That means almost same, that one A, B, C, D, same by rotation. The permutation, circular permutation we are forming by rotation, correct? That is what we are calling the identical permutation. These permutations are identical, okay? So this is one example, that one. Now, how many distinct permutation, different permutations? See, number of the circular permutation of n different object. Number of circular permutations of n different object is equal to, what is the rule here? N minus 1 factorial. We can create n minus 1 circular permutations, okay? For example, okay, what I discussed here. How many objects are here? 4 colors are there: red, yellow, blue and green. So how many, what is the n value? N value equal to 4. So how many circular permutation I can form? Number of circular permutation equal to n minus 1 factorial. That is the rule, correct? So what is n minus 1? 4 minus 1 factorial. 4 minus 1 factorial means 3 factorial. You can check by calculator how much you are getting. 6. So how many ways we can arrange that 4 object around a circle? 6 ways we can arrange. That are the 6 option here I am given. Okay, this is the first, second option, third option, fourth option, 5, 6. These are the 6 option we are getting. Different option. Okay, not identical permutation. Different options we are getting. So n minus 1 factorial we are getting. So what I discussed, linear permutation means objects are arranged in a line or a row. Circular permutation means objects are arranged in a circular, correct? Circle. So that is what the two permutations. Okay, now I hope you understood this idea, circular permutation and linear permutation. Now we will do some examples here. After that we will come to the exercise questions. Example, okay. In how many ways 4 persons can be seated around a circular table? We have 4 persons. They want to sit around a circular table, correct? How many ways person can be seated in a circular table? Okay, so circular, you can see the circular. Circular means circular permutation. Okay, circular permutation. So the number of ways 4 person can be seated. What was the rule we are studied? Circular permutation, n minus 1 factorial. Correct. What is n number here? How many persons are there? 4 persons. N equal to 4. So how many circular permutation we are getting? 4 minus 1 factorial, 3 factorial, 6. Just now we discussed that one, equal to 6. See, what are the 6 permutation, circular permutation I shown here? See, 6 person. This is the first person, second person, third person and fourth person, correct? 4 person. They are sitting around a circular table. So how many ways they are arranged, you can see one by one, correct? The 4 ways. Okay, you can represent A, B, C, D also, so that you can get like this. Okay, so this is simple idea, circular permutation. Okay, now before going to next exercise example, just to see what is the relation between the linear permutation and circular permutation. What is the relation connecting the linear permutation and circular permutation? What is the rule actually? This is the relation. Okay, linear permutations, number of linear permutations equals n multiply circular permutation. N multiply circular permutation. A simple example I will tell you that one. For example, math, the word math. Okay, the word math. If I am arranging this word as linear, okay, linear like a row, how many linear permutations are there? Okay, how many linear permutations are there? And same word if I am arranging in a circular way, circular, correct, circular permutations, how many circular permutations are there? This is what our question, correct? So linear way means like this, correct, M A T H, math, 4 letter word, correct. M is the first, A is second, A, T and H. Different way if you are arranging. What is the linear permutation we are getting? How many ways we can arrange the letters of the word math? Permutation of totally 4 letters we have. How many we are taking at a time? 4 letters we are taking, correct. Permutation of out of 4 letters, 4 we are taking at a time, correct, because math 24 we are getting, 24, correct. Now same math I am arranging in a circular way. How many circular permutation? That means here I am writing M and A, T and H, correct. How many ways in circular way I can arrange that one? That is n minus 1 factorial, correct. So what is that one? N minus 1 factorial. What is n number? N equal to 4. So 4 minus 1 factorial. What is 4 minus 1 factorial? 3 factorial, 6, correct. N number, as I told you, totally we have 4 letters. So totally 4 letters means linear permutation we are getting 24, but circular permutation, how many permutation I am getting? Equal to only 6. So what is the relation connecting the circular and the linear permutation? I told what is the relation connecting the circular and linear permutation. Okay, what is it? How many circular permutation we are getting? 6. How many linear permutation we are getting? 24, correct. And what is n? 4. So this rule you can see, linear permutation equal n multiply circular permutation, correct. Linear permutation equals n, total number of letters, multiply circular permutation, correct. Circular permutation. This example you can see, how many linear permutation? 24. So here we are getting 24. What is n? How many letters are there? You can see how many letters? 4 letters, correct. So 4. How many circular permutation? 6. Is it correct or not? You can see 24 equal 4 multiply 6. 4 multiply 6 means same 24 we are getting. So this is the relation connecting linear permutation and circular permutation. Okay, always circular permutation will be less, linear permutation will be more. So total object multiply circular permutation, you will get linear permutation, total letters. Okay, 4 multiply 6 equal to 24. So this is the idea. So you can just okay, memorize this one, linear equal to n multiply circular. Or you can write like this also. Okay, another way it is written here, circular permutation equal to linear permutation divided by n. Okay, when we are taking circular from here, divide both side by n, you will get this expression, circular permutations equal to linear permutation divided by n also. Okay, so this is the relation connecting linear permutation and circular permutation. Hope you understood that one. Okay, now let me come to the next example. This example, how many ways 6 persons can be seated? How many ways 6 persons can be seated around a circular table? Circular permutation. How many person? Totally n equal to 7, correct. N equal to 7. So number of ways 7 persons can be seated is, what is the rule? Circular permutation, n minus 1 factorial. 7 minus 1 factorial, 6 factorial. When you are entering your calculator, you will get the answer equal to 720 ways we can arrange. 7 pupils around a circular table, 720 ways we can arrange that one. Hope you understood that one. Okay. Now, let me go to the next one here. Permutation when all the objects are not distinct. Okay, permutation when all the objects are not distinct. So I will tell you one example here. See, for example, math, M-A-T-H. Now if I am writing M-A-T-H-E, mathematics, for example, if I am writing the word mathematics, okay, see the difference. How many letters are here? 4 letters, n equal to 4, correct? Is it distinct or not distinct? It is distinct, correct? It is distinct because all the letters coming how many times? Only one time. All the letters are coming only one time. M coming only one time, A coming one, T only one, H also one. So n equal to 4, distinct. Now here, check these letters. Is it distinct or not distinct? Not distinct because M coming how many times it is? 2 times, correct? A coming 2 times, another letters, some letters are repeating, correct? So these type of words we are calling not distinct. Okay, this word we are calling not distinct because the letters are repeating. So how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters, correct? N equal to 11. 11 letters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters are there. So not distinct. So we studied already how to find the permutation from here. Math, how can we find the permutation? We already studied that one, correct? Permutation of 4 object, 4 taking at a time. So you will get 24, correct? But what about the permutation here? How many ways we can arrange this word? This mathematics word, how many ways we can arrange? That is what our question. How many ways we can arrange the word mathematics? Okay, what is the permutation? That how many permutations? So that is what here we are studying. Permutation when all objects are not distinct means, for example, we have n object, contain p1 object of first kind, p2 objects of second kind, p3 object of third kind, etc. Like that, continuing, pk objects of kth kind, and p1 plus p2 plus p3 plus p4 up to pk equal to n. Then the number of permutation of n object equal to, we need to use this rule. What is the rule? N factorial divided by p1 factorial multiply p2 factorial multiply p3 factorial multiply, like that, last pk factorial. This is the rule for finding if the objects are not distinct. Okay, if the objects are not distinct, this is the rule, n factorial. What is the rule actually? N factorial means total letter. For example, here 11 factorial divided by, what is p1? P1 means m letter coming how many times? First letter coming how many times? For example, m here coming 2 times, so 2 factorial. P2 means second letter A letter coming how many times? For example, here 2 times, so 2 factorial. P3 means third letter T, how many times? 2 times, 2 factorial. P4, same like all the letter how many times coming? That factorial. First letter how many times? Factorial. Second letter how many times? Factorial. Like that, all the option. That is the total number of permutations of n objects. Okay, we can write like this. So this is the idea here, all the section 4.3.1, the module permutation. Okay, so I hope you understood that one. When we are doing question, I will tell you more. So for example, one of the example, whatever we discussed now, that same example. Okay, for example, how many arrangement means permutation, can be made with the letters of the word mathematics. Okay, how many arrangement can be made with the letters of the word mathematics? So I can write here, for example, mathematics, mathematics, correct? So first check m letter how many times coming. You can write that one. M letter. You can just put tally here. Before counting that one, keep in your mind this word is not distinct. Okay, not distinct. This word is not distinct. Keep in your mind that one. It is not distinct. Correct? Mathematics. So not distinct case, just count each letter how many times coming. For example, M. How many times coming? Here M is there. Correct? Here M is there. 2 times. So 1M, 2M. So M coming 2 times. Next A letter. How many times it is coming? You can check. A letter, here 1, here 2. So A letter 2 times. Next T letter. How many times it is coming? You can see. Here 1, here 2. So T letter 2 times. Now H letter only 1 time. Correct? E letter also only 1 time. And I letter also only 1 time. C also 1 time. S also 1 time. Correct? All other letters 1. H1, E1, I1, C1 and S1. Now you can add totally. Okay? For example, this 2, M letter 2 times. This is we are calling P1. This is 2, P2. Second letter coming 2 times. P2 equal to 2. This is P3. Same like this is P4, P5, then P6, then P7, P8. 8 letters are there, but totally how many times it is coming? You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Correct? Totally how many letters? 11 letters. Correct? N equal to 11. When you are adding P1 plus P2 plus P3 plus P4 plus 5, P6, P7, P8, if you are adding all these number, you will get 11 totally. 2 plus 2 plus 2, 1 plus 1 plus 1 plus that all. N equal to 11. Correct? N equal to 11. Now answer the first part of the question. What is the first part of the question we need to answer? That is, how many arrangement can be made with the letters of the word mathematics? Okay? So total number of ways. Correct? Total number of ways. Total number of ways equals, what is the rule? If not distinct, our word is not distinct. So what is the rule? N factorial divided by P1 factorial multiply P2 factorial multiply P3 factorial multiply. Last we can write, put some dot and write last P8 factorial. Correct? N factorial divided by P1 factorial, P2 factorial up to P8 factorial. Now you can check by calculator. What is N here? 11. 11 factorial divided by P1. What is P1? 2 factorial. Multiply P2 means 2 factorial. Multiply P3 means 2 factorial. P4 means 1. Once no need to write because 1 factorial means 1 itself. If you are writing also no problem, but no need to write because 1 factorial is 1. So 11 factorial divided by 2 factorial, 2 factorial, 2 factorial. You can check what is this number actually. I can get it, this number. It is bigger number, correct? 4989600. 4989600. 4989600. I hope you understood. So mathematics, the word mathematics we can arrange. How many ways we can arrange? This many ways. 4989600. It's bigger number, correct? So that many ways we can arrange. 49,89,600 ways we can arrange. Bigger number, correct? This is the first part of the question. Hope you understood. Now what is the second part of the question? How many ways of these words, vowels all together? See, total ways means 4989600. Out of this 4989600, how many of these words vowels all together? All vowels should be together. Okay, all vowels should be together. That is the question here. You know what are the vowels letters? A, E, I, O, U. Correct? A, E, I, O, U. That are the vowels. So here you can see A letter is there, then A, E is there, I is there, A, E, I, O, U, correct? A, E, I, O, U. So there is no letter other, only these three, correct? 1, 2, 3. So what I do now to answer the second part of the question, you can see, answer the second part. What you do now, just create a box like this, then easy to understand that one. Okay, just I am creating a box like this. There are two parts. What are the two parts? One is the vowels, all should be together, that is the meaning. Vowels all should be together. This is not vowels, next part. So what are the vowels we identified? You can see there, correct? So A 2 times coming, so I am writing here A letter coming 2 times, then E letter 1 times, correct? So I can write E letter 1 times, and another one, you can see I letter 1 time, I letter 1 time. Now remaining letter we can write the next box. What are the remaining letter? M coming 2 times here, so I can write M2. What are other? T2 and H1, T2 H1 and C1 S1, C1 S1, correct? So you will get, you written all the letters, correct? You can check that one. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, correct? Now, so vowels falls all together, then these many ways we can write. Now what you do now, this all vowels take like a single object. This all vowels together like a single object, like one object, this one. Why we are taking one object? Because whenever we are forming the word, all vowels should be together. All vowels should be together. That means this A, E, I, these letters should be together. So maybe A 2 times are there, E 1 time, I letter, these should be together. Or other letter we can arrange M, okay, T, H, M, C, S, T, like this we can arrange different way, but this should be together. Inside this also we can arrange, no problem. E, I you can write first, E you can write first, A you can write first, like that. Here also we can arrange. So first what I am doing now, first I am doing all the vowels I am taking as a single object, okay, as a single object. So this is one object, and here you can see how many objects are there totally. M 2 times, T 2 times, H1, C1, S1. So 2 plus 2 plus 4, 5, 6, 7, correct? Here 7 object, different objects, 7 objects. So one object plus 7 object means totally how many objects we have? 8 objects totally, correct? 8 objects we have totally getting. Are you understood? I hope you understood. Vowels all should be together. So vowels, these are the vowels. I am taken that together as a one object. Another 7 object will be there. So totally we have 8 object. Now think about these objects are distinct or not distinct? Not distinct, correct? You can think about this object. These are not distinct. Why not distinct? Because M coming 2 times, correct? T coming 2 times, H coming 1, C coming 1, S coming 1. If objects are not distinct, how many ways we can arrange that? How many permutation we can form? Objects are not distinct. We are studied. What is the rule we are studied? Not distinct. Permutation equal number of ways equals number of ways equals n factorial divided by p1 factorial, p2 factorial, p3 factorial, like that. You know that one, correct? So I am not writing the rule here. So number of ways here, how many total object? What is the n? 8 objects. So 8 factorial divide, okay, totally 8 objects, because 1 object plus 7 object, 8 objects. So n equal to 8 factorial divided by, what are the repeating number? You can see 2 factorial multiply 2 factorial, correct? 1 we are not writing here, 2 is there. See, I am rounded here 2, here 2, correct? Okay, don't look here, don't look, because this is single object. A2, don't take that 2, this is taken as single object only one time, like that is why we are not writing that down. Are you understood? You getting that one? So 8 factorial divided by 2 factorial multiply 2 factorial. Check your calculator, what is that number getting? I will just write here that this is the number 10080. Okay, I can write here 10080. This many ways. Okay, number of ways means 10080 ways we can arrange. Correct? Now see, this is only taken as a single object. After taking single object, this many ways we are getting. Now you can think about that one. Correct? What is we are thinking? This object, this single object we can arrange in different way. This vowels itself we can arrange in different way, because A coming 2 times, E coming 1 time, I coming 1 time. Correct? This is we are freezed now. Now just unfreeze this one. You can take I first, no problem. I, A, E, I, like that you can arrange. You can take E first. So E, A, I, like that different way we can arrange this 5 object itself. This freezer object, this one object we can arrange different way. So think about this one now. Okay, this one, how many ways we can arrange this one? Okay, number of ways we can arrange. How many ways we can arrange? Can you tell me this one? How many object here totally? Now think about not one object, different object. A 2 times, E 1 time, I 1 time. Correct? How many object? 2 plus 1 plus 1. 2 here, 1 here, 1 here. So 4 objects totally. Correct? And A coming 2 times. So is it distinct or not distinct? Not distinct. Correct? Not distinct, because A coming 2 times. So how many permutations we can form? How many ways we can arrange that one? Just to use n factorial, just to use the rule n factorial divided by p1 factorial, p2 factorial, like this rule. Correct? So how can we write, students, how many ways? How many objects are there? 2 plus 1 plus 1, 4. So 4 factorial divided by, okay, A coming 2 times, so 2 factorial. E only 1 time, so 1 factorial, no need to write. I 1 factorial, no need to write. So 4 factorial by 2 factorial. Check what is the answer getting. You will get 12. Correct? So I can write here equal to 12 here. I hope you understood that one. Correct? What I did, here it is 12. Here it is 1080. So in brief like this, see, I have like this 2 object. Vowels will be there here. Here not vowels. So first totally how many ways we are arranging, we are calculating. This one freezing. Correct? This is freeze, and how many ways totally we are calculating. Take it as one object, this one, and plus how many here, total object divided by repeating factorial, like that one. After that one, this one you unfreeze this part. Then this only how many ways we can arrange. Then multiply these 2 number, that is the total ways. Multiply these 2 number, that is the total ways of arrangement of that all vowels are together, such that all vowels are together. So now I am writing total number of ways. All vowels are together, how many ways? Okay. So we can write here number of ways. What number of ways? All vowels are together. All vowels are together. Totally how many number of ways? We can write this one. What we do? 12 multiply 10080. We multiply these 2 numbers. Correct? You can check by using multiplication rule. You can check by calculator. 12 multiply 180. Correct? You will get the number 120960. Bigger numbers. 120960 ways we can arrange. All vowels should be together, like that. Okay. So this is the second part of the question. In how many ways of these words all vowels are together we can arrange? So we got the answer. Totally 4989600 way. All vowels are together means we can arrange 120960 ways. Now we can go to the third part of the question. How many ways of these words begin with the T letter? This is also how many ways out of these words begin with the T letters. Okay. So we will go to that third part of the question. So for that answering, as I told you, I am putting a box like this. Okay. Now starting should be which letter? It is mentioned in the question. Word begin with the T letter. Starting it should be T letter here. Correct? T letter. Now in our question, T coming how many ways it is coming? T coming it is 2 times. Correct? M coming 2 times, A coming 2 times, T coming 2 times, and H1, E1 and I1, C1 and S1. Correct? Out of these letters, begin should be T letter. Starting should be T letter. See this one. Okay. So here I am writing 1 because 1 T I am written here. How many T's we have? We have 2 T's. 1 T I am written here starting. It should be T starting letter. Now another T I can write here. Okay. Totally 2 T's are there. 1 T I am written here. 1 T next column I can write. Okay. Now what are the remaining letters you can write here? M coming 2 times. A coming 2 times, H coming 1 times, and E coming 1, I also 1, C 1, S 1. This is the idea. You understood? First letter should be T, one of the T. We have 2 T's, but 1 T should be the first letter. So T. Okay. So 1, 1, 1, 1 like that we are getting. This is the total one. Okay. So 1. Totally you can see how many letters now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11 letter totally. Correct? Now you can think like this students here. For example, here how many letters are there totally? We have 10 letters. Correct? Because totally 11 letter we have. N equal to 11 totally. But out of N equal to 11, first letter should be T letter here, 1 letter, correct? 1 letter will be here, okay? 2 out of 2, 1 letter I am written here, okay? Then totally we have 10 letters balance. So totally how many permutation we can form like this? This is what our question we need to do. Totally how many permutations we can generate like this, okay? So we can see out of these 10 letters, students, what is the permutation actually? These 10 letters, how many ways we can arrange that one? Leave it the first letter. Leave it the first letter. So how many ways we can arrange the remaining 10 letters? You can think, is it these letters are distinct or not distinct? Not distinct, correct? Not distinct, correct? So if it is not distinct, what is the number of permutation, number of ways? Number of ways equals, not distinct. So n factorial divided by p1 factorial, p2 factorial, p3 factorial like that. So how many letter? 10. So 10 factorial divided by, correct? Which are the repeating only, right? M repeating 2 times, 2 factorial. A repeating 2 times, 2 factorial. And other all 1, correct? No need to write. So 10 factorial divided by 2 factorial multiply 2 factorial. You can check what is that answer getting. You will get this one, this number 907200, 907200. This many ways, correct? Only this second part, correct? Here only one option we will get it. Only 1 T, 1 letter, correct? 1 T. So totally how many ways we are getting? Number of ways, correct? Number of ways equals 1 multiply 907200, correct? So we will get 907200. This many ways totally we are getting. First letter T means these many ways we can arrange. The word mathematics. Okay, so 907200. I hope you understood this question, correct? So you can see the answers here. It is mentioned here, all the answers. 1 multiply 10 factorial divided by the numbers. Hope you understood this question. So what we are studied in brief, I am giving here. What we are studied in brief, you can see here. What are the ideas? First we are studied number of permutation of n different object taking r at a time. If objects are not repeat, p PNR, correct? PNR, that means n factorial divided by n minus r factorial. Repetition allowed, we are studied n power r. Repetition allowed, n power r. Number of circular permutation, after that we are studied n minus 1 factorial. Number of circular permutation. Now, if permutation when all the objects are not distinct, permutation when all the objects are not distinct means we have n factorial divided by p1 factorial, p2 factorial, p3 factorial up to pk factorial. Hope you understood. Okay, now we will come to the exercise now. So whatever the idea we are studied, we can do in the exercise questions. Okay, first question. How many ways 4-letter code, how many 4-letter code words are possible using first 10 letters of English alphabet? If no letters are repeated, no letters can be repeated. How many letter code you need to generate? 4-letter, correct? 1, 2, 3, 4, correct? 4-letter code you need to create. How many letters are available? 10 letters available, 10 letters of English alphabet. So totally how many? N equal to 10, correct? Out of 10, how many letter code you need to create? 4-letter code. So what is R number? R number equal to 4. 4-letter code we are creating. So how many ways we are creating? Number of ways. Number of ways equals permutation of, okay, how many object? 10 object. How many we are taking at a time? 4. So P10 4. What is P10 4? 10. You can enter calculator like this. 10P4. So that you will get the answer 5040 ways. Correct? 5040 ways. Okay. Now the same question as I told you, we can do another way, or you can do like this. Okay. How many 4-letter code we can create? How many 4-letter code words are possible? That is the question. Using 10 letters. So 4-letter code word, first letter, how many possibility? We have 10 English alphabet. So 10 code possible. Second one, repetition not allowed. So 9 code possible. One written first column means 9 available here. Now third one, how many available? 8 available. Fourth one, how many? 7 available. So totally how many? 10 multiply 9 multiply 8 multiply 7 by multiplication rule. So same answer you are getting, that is 5040. So one of the way you can answer in questions, okay, either this way or this way, both are same only, but as per your understanding. Okay, let me go to the second question. Question number 2. There are 10 true or false questions in an examination. There are 10 true or false questions in our examination. How many sequences of answers possible? How many sequences of answers possible are possible? That is the question. How many sequences of answers are possible? Okay, so let me do this one. You can see there are 10 true or false questions. Okay, so I can write question number 1, question number 2, question 3, question 4, question 5, 6, question 7, correct, 9, 10 questions. Okay, there are 10 true or false questions. So each question, how many options? Either true or false. True or false, all question. True question or false question. True or false, correct? All like that. Like this, correct? Either true or false. That means question number 1, how many possibilities answer? Either true option or false option, 2 options. Second one, how many? 2. Third one, 2. Correct? So all true, false, like 2 options will be there. So total number of answer, how many sequence of answers are possible? So how many sequence? 2 multiply 2 multiply 2 multiply all number of 2. How many 2's are there? 10 2's, correct? So we can write 2 power 10. 2 power 10, because 2 coming 10 times. 2 power 10. What is 2 power 10? 1024. 2 power 10 means 1024 possibilities. Okay, 24 sequence of answers possible. 1024 sequence of answers possible. Hope you understood that one. Okay, now question number 3. How many even numbers? How many even numbers of 3 digits can be formed? How many even numbers of 3 digits can be formed with the digits 1, 2, 3 up to 9 if no digits repeated? Okay, so this is the important idea. How many even numbers? That is the question. Even numbers, correct? Even numbers means what are the even number? 2, 4, 6, 8, like these numbers, correct? Or 12, 14, 16, 26, 46, like this many numbers are there, correct? So like this even number, how many even numbers are possible with the digit 1 to 9 if not digit repeating? And keep in our mind how we are identifying even number. For example, 26, even or odd? Even number, because last digit is an even number, correct? 12, is it even or odd? Even, because last digit is even number, correct? 27, is it even or odd? Odd number, because last digit is an odd number, correct? 29, is it odd or even? Odd number, because last digit is an odd number. So depends on the last digit a number is identifying even or odd, correct? Now think about this question. How many even numbers of 3 digit? Okay, how many even numbers of 3 digit? So for example, first digit, second digit, third digit, 3 digits it should be even number. Even number means, think about the last digit possibility. What are the possible digits last? Because it should be even. Is it even means what are the possibility of the last digit? Either it should be 2 or 4 or 6 or 8, correct? So we can write here either number should be 2 or 4 or 6 or 8. That means how many possibilities are there? We have 4 possibilities. I am writing here either 2 or 4 or 6 or 8, correct? Totally how many number we have? Totally we have 10 number. 9 number, 1 to 9. N equal to 9, correct? Totally we have 9 numbers. Out of 9 numbers, 4 number here possibility. Okay, these are the possibility. But how many number we are writing there? Only one number, correct? One of this number we are writing. Either we are writing 2 or we are writing 4 or 6 or 8, like that. One of the number. But 4 possibilities are there. Now these 2 digit, how many numbers possible, students? These 2 digit. Okay, totally 9 number. 1 digit here we are writing. Out of these 4 number, 1 digit, 1 number we are writing here. So how many number here balance? 8 numbers are balanced, correct? 8 numbers are balanced, because totally 9 number. 1 number we are writing last digit. Here 2 number. So 8 possibility here we are getting, correct? Repetition not allowed means here 7 possibility will get it. Okay, so totally how many possibilities? 7 multiply 4 multiply 8, 8 multiply 4. So totally how many it is? Total number of ways equal to 224. Total ways is 224 ways. Hope you understood that one. Don't confuse with the last number. Last number I wrote 4 means 4 possibility, correct? 2, 4, 6, 8. But how many number actually we are writing? Only one number, one of this number. So remaining how many number? 8 number, because totally 9 numbers, correct? So we are getting multiply 2 to 4 we are getting. Now the same question if you are doing another way. How can we do another way? That one, it is 3 number, 3 digit, 1, 2, 3, correct? 3 possibility. Now how can we write this one? Last digit, as I told you, how many possibility we have? 4 multiply, correct? Here how many number balance? 8 number balance, correct? 8 numbers. How many we need to take at a time? 2 needed, correct? N equal to 8 here. R equal to 2 needed. 2 boxes we need to fill. That is the meaning 2. So what is the permutation? Permutation of 8 objects, 2 taking at a time. Multiply 4. The same answer you will get 224. So one of the way we can answer this question 224 here. Hope you understood this question. How to do, correct? Okay. Now let me go to the next question. Question number 4. As you know, this is little lengthy section. So we will answer now this one. How many words can be formed using the letters of the word equation? How many words can be formed using all the letters? Okay, that is the important. All the letters of the word equation. What is the word? E-Q-U-A-T-I-O-N. Equation. How many letters are there? That one. And first thing, is it distinct or not distinct? E coming one time, Q one time, A one, U one time, A one time, T one, I, O, N. All letters one time. So this word is distinct, correct? All the letter at the time, only one time. Now totally how many letters are there here? N equal to 8 letters, correct? 1, 2, 3, 4, 5, 6, 7, 8. 8 letters. How many we need at a time? All the letters. So what will be the permutation? Number of ways equals permutation of totally how many letter? 8. Taking how many at a time? All the letters. So 8 at a time. Correct? Because n equal to 8, r equal to 8. R equal to 8 means all letters. All the letters at a time. So what is P88? You can see 8 permutation 8. What is the number? You will get 40320. This is the number of ways totally. Correct? Hope you understood the question. 40320. Okay, now let me go to the question number 5. What is question 5? How many ways can 5 flags? How many flags we have totally? 5 flags. That means n equal to 5. Totally we have 5 flags are there, in which 3 are red. 3 flags are red. So I can write R, R, R. 3 red flags. Okay. And 1 white flag. Okay. 1 flag is white. And 1 is blue flag. Okay. 1 flag is blue flag. Okay. 3 red flag, 1 white flag, and 1 blue flag. Okay. You can see, is it distinct or not distinct? Not, correct? Not distinct. Because R coming how many times? 3 times, correct? I can write here, because R coming 3 times, W coming only 1 time, blue also coming only 1 time. Correct? Totally we are having 5. Okay, n equal to 5. So you can see, okay, R coming 3 times means this is P1. 1 time P2. 1 time P3. Okay, because not distinct. Not distinct. Now what is the question actually? Okay, how many ways these 5 flags can be arranged on a stuff? Stuff means this one. Okay, this flag, so you can see one picture here. This is stuff. Okay, this stuff, how many ways the flag can be arranged one over other? Okay, first we put one red flag, then one white flag, then red flag, like this one over other, arranging this 5 flag. How many ways we can arrange on a stuff? That is the question here. Correct? So how many ways we can arrange this one? RRRWB. That is our question. This not distinct word. How many ways we can arrange? Okay. How many ways we can arrange? Number of ways equals. Number of ways equal. Totally how many letters? 5 letters. So 5 factorial divided by, because not distinct. Not distinct means what is the rule? N factorial divided by P1 factorial, P2 factorial, you know that rule, correct? If you want, you can note N factorial divided by P1 factorial, P2 factorial multiply P3 multiply, like that, correct? P3 factorial multiply. So what is n? 5. So 5 factorial divided by P1. P1 means R coming 3 times, 3 factorial. Next 1, no need to write. 5 factorial by 3 factorial. What is the answer? 20 ways we can arrange. Totally 20 ways we can arrange the flag one over other on a stuff. I hope you understood this question. Okay. No distinct permutations. Okay. Next, question number 6. Question number 6 now. What is the question? 4 persons A, B, C, D are to be seated on a circular table, circular permutation. We have a circular table like this. 4 persons, first is A, B, C and D, be arranged, be seated. How many ways they can be seated? That is the question. So how many persons are there? N equal to 4. Circular way. So circular permutations. Number of circular permutations equals n minus 1 factorial. Correct? We studied the rule. What is n? 4. 4 minus 1 factorial. What is 4 minus 1 factorial? 3 factorial. That means 6 ways. Correct? We can arrange 6 ways around a circular table, seated at a circular table. Hope you understood that one. Correct? Okay, now let me go to the next question. 7. Question number 7 and 8, little lengthy question. You can be careful that questions. Question 7. In how many of the distinct permutations of the word Mississippi do the 4 I's not come together? Do the 4 I's not come together? How many distinct permutations of the word Mississippi? This is what our 7th question. Okay. So think about the word first. What is the word? Mississippi. Correct? This is the word we need to consider. Mississippi. Correct? Now this word, how many letters we have this word? You can count it. Before counting, is that word is distinct or not distinct? Not. The word is not distinct. Now each letter how many times coming we can just write. M letter how many times? Only 1. I letter how many times you can count? 4 times it is coming. Okay. S letter how many times? 4 times coming. P letter how many times? 2 times it is coming. Correct? So totally you can check it. 4 plus 4 8, 8 plus 2 10, 10 plus 1 11. So totally n equal to 11 letters we have. Out of that some letters are repeating. So not distinct case it is. Okay. Now before coming to the question, just calculate what is the total number of ways. Total number of ways this word can be arranged. Total number of ways. Mississippi word arranging. What is the permutation? Not distinct means n factorial divided by p1 factorial, p2 factorial, like, correct? This is p1. This is p2, p3, correct? And p4. So what is the total permutation? N factorial. That means 11 factorial. Divide. P1 factorial is 1, no need to write. P2 factorial means 4 factorial. P3 means 4 factorial. P4 means 2 factorial. Multiply, correct? You can use the calculator. You will get 34650 totally. 34650, correct? So this is the first idea. Total number of arrangement Mississippi. That word how many ways we can arrange? 34650. Now coming to the question. What is the question actually? How many permutation, distinct permutation can be created? All 4 I's are not come together. All the 4 I's will not be together. How many ways we can arrange? That is the question. All I's should not be together. Okay. So what I am doing now, first all i's are together. First this possibility I am checking. First for all i's are together. Our question is not together, correct? But I am finding first all i's are together. How many permutation? Then all i's are not together means what you do? Total minus all i's are together. That is the idea we are doing here. So you can just like previous questions, create a box like this. Okay, here all I coming together, take it as a single object. Okay, that one just take it as a one object, single object, one object, all i's are together. So how many i's are there in our question? 4 times, correct? I am writing I 4 times. Now what are the other letters? M coming 1 times, S coming 4 times, P coming 2 times, correct? These are the other letters. So totally how many objects are there? All I together one object we are taking. So how many objects here remaining? Here 1, 4, 2, 7 objects, correct? 7 objects. So totally how many objects we have? 1 object plus 7 object means 8 object. We did one question, same idea. 8 objects here, correct? So is these 8 objects are distinct or not? Not distinct, correct? Not distinct, because you know S coming 4 times, P coming 2 times. Here only one object, I power 4 not taking, I 4 times not taking, one object only, that one. But next side S coming 4 times, P coming 2 times, that is why not distinct. So how many ways we can arrange? How many number of permutation? Number of ways means, you can think, number of ways equal, not distinct means what is the rule? N factorial divided by P1 factorial, P2 factorial, like that, correct? How many object? 8 objects. So 8 factorial divided by, okay, 8 factorial divided by, which is repeating, S repeating 4 times, so 4 factorial, P repeating 2 times, so 2 factorial, correct? 8 factorial divided by 4 factorial, 2 factorial. What is that number? 840. 840 ways we can do, correct? Now what I told, this all I together I am taken now, all I together, correct? Now these i's, for example, how many ways this I 4 i's we can arrange? 4 i's, how many ways we can arrange? That is the next one, correct? Is it distinct or not distinct? Only this part, you can think now this part, I power 4, I 4 times. Is it distinct or not distinct? Not, correct? Not distinct. Okay, so how many ways we can arrange that one? Totally 4 i's are there, so 4 factorial divided by I coming how many times? 4 times, so 4 factorial. Actually it is what? 1. So if only one letter means 1 only, that is why some of the question directly you can write 1 here, no need to think that one, because 4 factorial divided by 4 means it will get 1 only getting. Now so number of ways totally, number of ways, okay, all I together, all i's together, what is the answer getting? All i's are together means what will be the answer? Here 1, correct? So 1 multiply here how much? 840. 840. So totally how many we will get? Equal to 840. 840 ways. So in Mississippi word, all i's are together means how many ways we can write? 840 ways we can write. Hope you understood that one. 840 ways we can write all i's are together means. Okay. Now what is our question actually? In Mississippi, do all i's not together, not come together, how many ways? That is our question. All i's are come together, we calculated. Now we will write the answer. All i's not together. Okay, not together. How we are calculating? All i's are not together, how many ways? Number of ways. Number of ways all i's are not together equal to, what you do? total. First we calculated totally how many ways we can arrange. Minus, what you do? All i's are together. Possibility. All i's together. All i's are together, just subtract. Number of ways, all i's are together. Just subtract. Okay. So total how much we are getting? Totally the word Mississippi, how many ways we can arrange this one? 3, 4, 6, 5, 0. Correct? So we can write here equal to, we can write that is 3, 4, 6, 5, 0 minus all i's are together. Just now we got how many option? 840 option. So how many we are getting totally? Subtraction 3, 3, 8, 1, 0. All i's are not together. This many ways we can arrange. 3, 3, 8, 1, 0 ways. So this is what our answer. So not together, whenever we are asking, together we will take, and total we are calculating, then total minus together we are taking, you will get not together options. Hope you understood. And now let me start question number 8 here. You can see question number 8. In how many ways can the letters of the word permutation be arranged? Okay. If words start with P and end with S letter, vowels all together, the vowels all are not together. So what is the word here? Permutations. Okay. So I am writing here permutations. Now think about this word permutations. Is it distinct or not distinct? It is not distinct. Correct? Why not distinct? Because some letters are repeating. For example, P coming how many times? One time. E how many times coming? One. R only one time. M also only one time. U one times. Correct? Then T is coming two times. Correct? Word T is repeating, so not distinct. A coming only one. I also one. O one. N 1 and S 1. So totally how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters are there. Correct? Totally we have 12 letters. That means N equal to 12 here. N we have 12 letters we have, because it is not distinct. That is T is repeating that one two times. Correct? Now we will answer the question one by one. First, how many permutation, how many ways can the letters of the permutation be arranged? That question first we can answer. Before answering part A, part 2, part 3, we will answer how many permutation totally we can form. That we can answer first. Okay. So we can answer total number of ways. Correct? Total number of ways equals how many letters totally? 12. So 12 factorial. Correct? Divided by 12 factorial divided by 1 factorial. No need to write 1, 1, 1, 1, all 1. Only repeating 1. 2 factorial. Correct? Here when we are writing P1, this is no need to write. P2, no need to write. P3, no need. Only write this one 2. 2 factorial. Correct? So you can check what is the answer getting. 12 factorial divided by 2 factorial. It is a big number. For example, you are getting this number 239 500 800. Correct? This is the total permutation. Okay, permutations word we can arrange these many ways. Okay. Now, what is the first part of the question? We will go to the first part of the question. Okay. Words start with the P letter. Words should be start with the P letter and end with S letter. Word start with the P letter and end with S letter. So I will answer here the first part. Just putting a box like this for your understanding. Okay. Word should be start with one letter, end with another letter. What is the starting letter? P. So here it should be P. here it should be S. Okay. How many times P coming here in our question? Only one time, correct? S also how many times? Only one time, so no problem. So P here 1, S also here 1. Okay. Now remaining letter you can think about the middle. So E coming only one times. Okay, P already written. E coming one time. R1, M coming one times, and U one times, T two times. Okay, this is what important here, repeating term. A coming 1, and I also 1, O one time, N one time, and S one time, correct? So totally you can see 12 is getting correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, correct? Totally we are getting 12. Now think about how many permutations, how many ways we can arrange this one, correct? So this first column, how many ways we can arrange? One way, because only one letter. Last column also, how many ways we can arrange? Only one letter, so one way. Now remaining here, think about here. Is it distinct or not distinct? Not distinct, correct? Because which is repeating? T letter coming two times, so it is not distinct. How many letters are there here? 10 letters, correct? 10 letters are there. 10 letters, not distinct. How many ways we can form that one? Why 10 letters? Because one letter written first, one letter written last. Totally we have 12 letters. So middle only 10 option. So this 10 option not distinct. How many ways we can arrange that one? 10 factorial, because n factorial divided by p1 factorial, p2 factorial, p3 factorial, like that. So 10 factorial divided by 1 factorial, all no need to write. T coming 2 times, so 2 factorial. Getting 10 factorial divided by 2 factorial. So totally how many ways we can arrange? So number of ways equals, number of ways equal. What is the value? 1 multiply 10 factorial divided by 2 factorial multiply 1. So what will be the answer getting totally? 1814400. When you are calculating, you will get this answer. Okay, permutations. Hope you understood the first part of the question. Okay, now we will go to the second part of the question. What is the second part? Vowels all together. All vowels are together means how many ways we can arrange? All vowels are together means. So I can go to the second question now. Question number 2. What is the question? Let me erase. So vowels all together. Vowels all together. This is what our question. How many ways? So I am just drawing a box for that, for better understanding. Now divide into 2. First part it should be vowels letters. Now what are the vowels in our question permutation? A, E, I, O, U, correct? So E is a vowel, correct? I will highlight E. This letter is vowel. A, E, I, O, U is a vowel. A vowel. I vowel, O also, A, E, I, O, U. You can check that one, correct? A, E, I, O, U. So E coming, U, A, I, O. These are the vowels letters are correct. Correct? E coming one time, U one times, A one times, I one times, O one times. So I can write that in the first box. Okay. So E letter 1, U letter one time, A letter one time, I letter one times, O letter coming one times, correct? Remaining letter we can write in this second box for better understanding. What are the remaining? P is coming like 1, and E already we written, R letter coming 1, and M letter, that is 1, U already we written, T letter coming 2 times, A already written, I written, O also written, N one times, and S one times will come, correct? So what we do now? We are just taking this object as a single object. This is one object. All vowels taken as one object. Plus here how many object you can think about that one? 1, 2, 3, 4, 5, 6, 7. See 1, 2, 3, 4, 5, 6, 7. One letter we are missing. So P letter is there. R, okay. E already written there. And R letter is there. M letter 1. U letter already we are written there. T letter 2 times. A letter already written. I letter already written. O letter already written. N 1 times. And S 1 times. Correct? Correct only. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And totally we have 12. Correct only. So we have 7 objects here. Correct? 7 objects. So 1 object plus 7 object means totally how many objects? 8 objects. Correct? Totally 8 objects, because we are freezing the vowels part. 1 object, taking as 1 object. So if it is 8 object, check this is distinct or not distinct. Not distinct. Why not distinct? Because T coming 2 times. Correct? First part always distinct because it is taken as 1 object. Okay. Second part not distinct. So how many permutation totally we can form that one? Number of ways. Number of ways equals, not distinct means what was the rule? N factorial divided by P1 factorial, P2 factorial, like that. So N factorial means 8 factorial divided by which letter is repeating? T letter 2 times, 2 factorial. Correct? What will be that number? 20160. You can check by calculator. 20160. Correct? Now think about the first part now. The first part, this vowels part. Okay. Now unfreeze this one. Now it was freezed. Now unfreezing that one. How many permutation we can form with that letter? E, U, A, I, O. Okay. So think about that one. Is that letters are distinct or not distinct? It is distinct because E coming only 1 time, U 1 time, A 1 time, I 1 time, O 1 time. So these are distinct. Correct? No, it is distinct. Correct? So if it is distinct, how we are finding the how many ways arrangement permutation? Permutation of how many letters are there? 1, 2, 3, 4, 5 letters. Correct? How many we are taking at a time? 5 letters. Correct? So P55. If it is not if it is distinct means direct permutation. We studied beginning permutation of the 5 letter, 5 taking at a time. P55. Correct? What is P55? You can check by calculator. 120. 120 ways. Distinct. Distinct means PNR. That is the rule. PN, R. What is the N here? Here we have 5 letters. Correct? 5 letters are there. So 5 letters, 5 taken at a time. 120 ways. Now we can write the total number of ways. Number of ways. Okay? That is vowels all together. Vowels all are all together. Vowels all together, number of ways equals, what we do? 120 multiply 20160. These two number multiply. So what you got the answer? 2419200. Bigger number. Correct? 2419200. This is the number of ways. All vowels are together case. Hope you understood this one. Okay, now the third part of the question. The vowels all are not together. Not together. Correct? We studied that one. We did one question that one. Correct? All vowels are not together. So vowels all not together. Okay, vowels all not together means what we do for that? Total number of ways minus vowels all together possibility. Correct? Vowels all together possibility. So you can check what the number getting. Vowels all together, not together equal total minus vowels are together. What is total we are getting? Initially we are written the number, this bigger number 239456. 500 800. Correct this number. Applying here 239 500 800 minus vowels all together we are written here. This one 241 9200. So what will be the answer? Equals 237081600. So this is the answer for that one. So I hope you understood the permutation section. Okay, this is logical ideas. So try to understand the ideas from these examples. Many options we did. So I hope you understood the idea. Thank you for watching. Okay, please subscribe my channel for getting more recorded classes. Thank you very much.